In 4.2, the quadratic relation, y equals ax squared plus k. Okay, this is going to be part 1, the a value. So a quadratic equation is written in the form y equals x squared. Okay, so we're going to first introduce what's going on when we have an a in front of the x squared. So when we have a number here, whether it's a positive or negative number, whether it's a fraction or a whole number, okay, all these different situations, what does the a value actually mean? Okay, so the graph, example 1, graph the equation y equals x squared using a table of values. So as a recall, when we're graphing y equals x squared, what we do is we sub in the x to exactly where the x is in the equation. So negative 3 squared is 9, okay, and then we sub in 2. So negative 2. Negative 2 squared is 4. Then we sub in negative 1. Negative 1 squared is 1. 0 squared is 0. And then we have 1 squared, 2 squared, and 3 squared. Okay? We get 1, 4, and 9. Okay, so if we graph this, and this is actually our x-axis, and then our y-axis, we're going to get, remember this negative 3, 9 is actually the point negative 3, comma 9. So we go negative 3, comma 9, and we plot a point. And then negative 2, comma 4. Negative 2, comma 4, and then we plot a point. Okay, negative 1, comma 1. We plot a point. 0, comma 0. We plot a point. We get 1, 1, 2, 4, and 3, 9. So 1, 1, 2, 4, and 3, 9. Oops. Oh, I put 8 there. My mistake. This is 9. Okay, so this is y equals x squared. And go ahead and label this graph by just putting the equation right next to it. Okay, let's talk about a couple things on this graph. So this graph, if you look down this middle where a vertical line would go through the vertex, so this right here would be the vertex. This occurs at 0, 0. And then all of these points are equidistant away. So this is symmetric. So the 9 plots off, negative 3 and 3 both plot onto 9. Okay, negative 2 and 2 both plot onto 4, negative 1 and 1 both plot onto 1. Okay, so and so on. You could take any number here, and if you plug in the positive and negative of it, all of these are going to be equidistant away from this axis of symmetry. Example 2. Graph the relations y equals x squared and y equals 2x squared on the same set of axes. So from the previous example, we're going to go ahead and plot y equals x squared. So 0, 0, 1 and negative 1. And I'm going to do this by doing like the symmetry. Negative 2. This is 1 and negative 1. Sorry, this axis, if you look, this goes up by 2's each time. Okay, so just be aware of that. Negative 2 and 4, and then 2 and 4. Okay, so that's going to be nicely symmetric. Then negative 3 and 9, which is going to be in the middle here, and 3 and 9. Okay, so this here is our original graph, y equals x squared. Okay, so that's all done in that pink color. Now, let's do this in the teal. We're going to graph y equals 2x squared. So what we want to do is we want to go down this entire chart, and we want to sub in negative 3. So y equals 2, negative 3 squared. Y equals 2, negative 2 squared. Y equals 2, negative 1 squared. y equals 2, 0 squared, y equals 2, 1 squared, 2, 2 squared, and 2, 3 squared. So when we calculate this, we are squaring only the -3. So we have to follow BEDMAS. So we want to square it first and then multiply it by 2. So -3 squared is 9 times 2 is 18. -2 squared is 4 times 2 is 8. -1 squared is 1 times 2 is 2. 0 squared is 0 times 2 is 0. 1 squared is 1 times 2 is 2. 2 squared is 4 times 2 is 8. And 3 squared is 9 times 2 is 18. So now let's go ahead and graph this. So we have -3, 18. So -3, 18. -2, 8. -2, 8 is here. Okay, -1, 2. 0, 0. And then this is symmetric. We can see that this is symmetric. Both of these are 2's. Both of these are 8's. And both of these are 18. So we'll have 1, 2 again. 2, 8. And 3, 18. Okay, and that's y equals 2x squared. So let's take a look at this. If we talk about which graph is skinnier and which one is wider, and remember this goes on and on forever, and this goes on and on forever, right? So when we talk about which one is skinnier, so we can see, let's do this in another color, green, okay? So we can see that y equals 2x squared is skinnier, if you want to call it, and y equals x squared is wider. Okay, and of course this is skinnier and wider than each other, right? We're just like comparing them, and that's going to come into play shortly. Okay, example 3, graph the relations y equals x squared and y equals 0.5x squared on the same set of axes. So I'm going to start with doing y equals x squared, and again, 0, -1, 1, and 1, 1, -2, 4, and 2, 4, -3, 9, and 3, 9. Okay, that's our original y equals x squared. Now, let's talk about y equals 0.5x squared. Okay, another way of looking at this is 1/2 x squared, right? 0.5 and 1/2 are the same thing. So let's go to our table of values and go ahead and sub in y equals 0.5 -3 squared. Then we're going to go 0.5 -2 squared. We're going to go 0.5 -1 squared. We're going to go all the way down, 0.5, 0 squared. And we're going to sub in our x values, 0.5, 1 squared, 0.5, 2 squared, and 0.5, 3 squared. Okay, so -3 squared, we have to square first because of BEDMAS. Okay, do the exponents before we do multiplication. So -3 squared is 9, half of 9 is 4.5. -2 squared is 4, half of 4 is 2. -1 squared is 1, half of 1 is 1/2 or 0.5 if we want to do that. 0 squared is 0, 0.5 times 0 is 0. And now because we've centered the vertex, these numbers are going to be symmetric. 1 squared is 1, half of 1 is half. 2 squared is 4, half of 4 is 2. 3 squared is 9, half of 9 is 4.5. And now we can plot -3, 4.5. Now, -2, 2 is here. Oh my God. Okay, -1, 0.5 is here. 0, 0 is here. 1, 0.5 is here. 2, 2 is here. And then 3, 4.5 is here. Okay, so y equals 0.5 x squared. So when we take a look at this, we can say that the graph of y equals x squared is the skinnier one. And y equals 0.5 x squared is wider. Okay, graph the relations y equals x squared and y equals -x squared on the same set of axes. So let's do x squared again. 0, 0, -1, 1, 1, 1. Okay, because remember those are symmetric. -2, 4, and that's symmetric with 2, 4. -3, 9, and that's going to be symmetric with 3, 9. Okay, so that's y equals x squared. Now what we want to do is we want to plug in our values in our table of values to y equals -x squared. So it's going to be -3 squared. Okay, don't forget the brackets. So it's negative, and then exactly where the x is, we're going to sub in our x from this column. -2 squared. -1 squared. -0 squared. -1 squared. -2 squared. And -3 squared. Okay, so just subbing in these x values all the way down. So when we look at this negative sign in front, we actually just treat it as like a -1. So again, BEDMAS, -3 squared is 9, and then it's -9. Okay, because it's like 9 times -1. -2 squared is 4, so our answer is -4. -1 squared is 1, so our answer is -1. 0 squared is 0, so that's just 0. 0 doesn't have a positive or a negative on it, it's neutral. Okay, 1 squared is 1, so we get -1. 2 squared is 4, we get -4. And 3 squared is 9, we get -9. So if you need to see the coordinates, you're -3, -9, -2, -4, -1, -1, 0, 0, 1, -1, 2, -4, and 3, -9. So -3 and -9 is here, and then 3 and 9 is here. Those are symmetric. Sorry, 3 and -9. -2, -4, and 2, -4 is here. -1, -1, 1, -1, and then 0, 0. Okay, so here is y equals -x squared. Okay, so if we're taking a look at these two are y equals x squared and y equals negative x squared are congruent in size. Congruent in size. Okay, so all we did is actually like flip it. Okay, one's opening up, one's opening down, but the actual size is the same. So here's the conclusion. When we have a positive a value, okay, there's two different situations. Not between -1 and 1. So essentially for the positive a, it would be not between 0 and 1. Okay, what this means is that our x value is greater than 0. Oh, sorry, greater than 1. Okay. When a is greater than 1, the graph appears vertically stretched. That means it gets skinnier. Okay, and when a is between 0 and 1, in other words, a fraction, okay, but it's not an actual fraction because we could have, for example, 5/2, which is 2.5. So it's not that, it's kind of like you're looking for a fraction or you're looking for a 0 decimal in some number. What this is going to give us is a graph that's vertically compressed. Okay, and then this is wider. Okay, now if the a value is negative, it's going to be when a is less than -1, our graph is going to be vertically stretched and it's going to be flipped over the x-axis. It's going to be that reflection. It's called reflection in the x-axis. That's what it's actually called. Okay, so it's flipped. Okay, so then that means it opens down. It's a sad face. Okay, and when a is less than 0 but greater than -1. Oh, I'm putting x. I mean a. I need to change these. Yep, that's it. Okay, when a is between basically -1 and 0, we're still vertically compressed, but because it's negative now, again, we're flipping over the x-axis.